Hi guys, Matambo here, and today we'll be discussing question 3 of the tutorial sheet. And this question covers unemployment. So the question covers unemployment. So question 3 says, suppose the production function is Cobb-Douglas with parameter beta is equal to 0.7, right? So we have a Cobb-Douglas function, and we know that the Cobb-Douglas function takes this form. So Q is equal to A K alpha L beta, right? Where we know that the alpha just shows the percentage of income that is used to compensate capital, and then beta shows the percentage of income that is used to compensate labor, right? Now if beta is 0.7, then alpha is 0.3. Why? Because we know that alpha plus beta is equal to 1. Okay, so the Cobb-Douglas production function in this case, we're assuming that it follows the concept, or it exhibits the concept of constant returns to scale. Therefore, our production function will be A, where A is A is just a metric that measures the productivity of these factors of production. Sometimes they say we can say that A is or measures technology. Okay, so therefore our production function will be A K to the power 0.3, then the labor to the power 0.7. So that is our Cobb-Douglas function there, right? So now the question is saying that what fraction, part A, what fraction of income do capital and labor receive? So what fraction of income do capital and labor receive? So the Crookes method is just by looking at the exponents, right? Since K is raised to 0.3, in short, since alpha is 0.3, then we can argue, which is true, that 30% of total income goes to the compensation of capital. And since beta, which is the exponent of labor, is raised to power 0.7, we can also argue, of course the argument is true, that 70% of total income goes to the compensation of labor. But we need to prove this mathematically. Okay, we need to prove this mathematically. So now what we know is that any profit maximizing firm will hire the units of labor and capital up to a point where the marginal productivities of these two factors of production equal their real price, right? This means that any profit maximizing firm will hire labor up to a point where the marginal product of labor is equal to the real wage. Okay, and this firm will also hire the units of capital up to a point where the marginal product of capital is equal to the real rental rate of capital, R over P. Great. So therefore this makes sense that if we are going to hire an extra unit of labor, okay, if we are going to hire an extra unit of labor, this unit of labor is going to bring in additional amount of output equal to the marginal product of labor. Therefore, to find the income, okay, to find the income that will go to the compensation of labor, we will just get the marginal product of labor, multiply it with the total labor units, okay, with the total units of labor. We'll multiply this by, so we'll first have to get the marginal product with respect to labor, then we'll multiply this by the units of labor, then we'll compare this to the initial amount of output. In short, it's the marginal product of labor multiplied by labor units divided by the total amount of output. Alright, so let's first get the total income that goes to the compensation of labor. Now, since our production function is Cobb-Douglas, we know that getting the marginal product with respect to labor will just differentiate partially the production function with respect to labor. So our labor is raised to power 0.7, so the 0.7 will drop, then we'll multiply this by a k to the power 0.3, then labor to the power minus 0.3, okay, which by now I know you know how to differentiate. Great. So this is just the marginal product with respect to labor, but the formula that we're using to get the income that will go to the compensation of labor is this one here. Okay, so total income that goes to the compensation of labor, that goes to the compensation of labor is this formula here. Okay, so it's the marginal product of labor times labor divided by the initial amount of output y. Okay, or divide this by q, which is the same thing. So we've gotten the marginal product with respect to labor, which is this. Then we know that multiplying the change in q by times labor, this will be 0.7 ak to the power 0.3, labor to the power minus 0.3. Then I'm multiplying this by L, okay, by L, the units of labor, and this will give us 0.7 ak to the power 0.3, then labor. So now we are going to maintain the base and add the powers. Okay, so this will just be negative 0.3 plus a 1. So this will give us 0.7 ak to the power 0.3, labor to the power 0.7. But now we have to divide it by y, where y is output and this output is q. So we'll divide this by q, which is a k to the power 0.3, labor to the power 0.7. Therefore, when we cancel everything out, we are going to remain with 0.7, which is 70%. So this means that labor receives 70% of total income. In short, 70% of total income goes to the compensation of labor. To find the income that is going to the compensation of capital, we do the same thing. So to find the total income that goes to, in short, to find income that goes to the compensation of capital, we use this formula, change in q per change in k. We'll multiply this by k, then this whole thing will have to be divided by q. So therefore, change in q per change in k, the marginal product with respect to capital, this will give us 0.3 ak to the power negative 0.7, right? The labor to the power 0.7. Great. Okay, so this is our marginal product with respect to capital, which we know that after getting the MPK, the marginal product with respect to capital, we need to multiply it by k. So this will be 0.3 a capital to the power minus 0.7, labor to the power 0.7. Then this will be multiplied by capital. So this will just be 0.3 ak to the power 0.3. Just maintain capital and add the powers. Then you have got labor to the power 0.7. We know that after doing this, we have to divide it by output q. So this will be divided by q, and our q is a capital to the power 0.3, labor to the power 0.7. Cancel out everything. This will give you 0.3 as your final answer, which is still the value of alpha, and the 0.7 is still the value of beta. And these show, so this, the alpha is equal to 0.3, shows that 30% of total income goes to the compensation of capital. Okay, so this is how we solve part A. Okay, so that is how we solve part A. Part B is saying, suppose that immigration raises the labor force by 10%, then what happens to total output in percentage, then also the real rental price of capital and the real wage. So what we know is that there is an increase in labor. Okay, so there is an increase in labor equal to 10%. Okay, what we want is to find the impact of this increase in labor on our output first. Okay, great. So our production function is AK to the power 0.3, then labor to the power 0.7, which means that our output Y is equal to AK to the power 0.3, then labor to the power 0.7, right? So let's call this our Y1. So our initial level of output before the increase in labor is equal to that. Then let's find our Y2. Okay, and this Y2 should now, have the impact, should now have the influence of this 10% increase in labor. So therefore our Y2 will be AK to the power 0.3 multiplied by labor, where there has been a 1 plus 0.1 increase in labor. Okay, so there's a 1 plus 0.1 increase in labor, and everything here has to be raised to power 0.7. So there is a 1 plus 0.1. The 0.1 is the 10% increase in labor. Okay, so in short, labor has increased by 10%. So this will be 1 plus 0.1, where the 0.1 is the 10. Right, therefore our Y2 is A K to the power 0.3, right, 1.1 L to the power 0.7. In short, our Y2 is just A capital to the power 0.3, 1.1 to the power 0.7, and labor to the power 0.7. In short, labor has increased by 10%. So to show the increase, we do 1 plus R. Okay, while this R is the growth. So there has been an increase by 10%, which means labor has increased by 10%. So we have to multiply the 1 plus R by labor. Now to find the impact of the increase in labor on output, we'll just say Y2 divided by Y1, where Y2 is the output after the increase in labor, and the Y1 is the initial amount of output. So our Y2 is what we've just found there, which is AK to the power 0.3, 1.1 to the power 0.7, labor to the power 0.7. Then we divide this by the initial amount of output, the AK to the power 0.3, then labor to the power 0.7. So this part will go, that guy will go. Therefore, to find the percentage change in output, it's giving us 1.1 to the power 0.7, right? And when we multiply this, it's going to give us something like a 1.069. Okay, so remember that when getting the growth, we added a 1. We said 1 plus. So to find the actual change, we would say this answer, the 1.069 minus a 1, which will give us 0.69. Now multiply this by 100. Okay, multiply this by 100, which will give us 6.9%. So this means that an increase in labor equal to 10% will increase output. Okay, this will increase output by 6.9%. Okay, Someone is calling. Let me pick the call. So I'll pause the video and I'll pause the recording and carry on. Yeah, so output has increased by 6.9%, right? Yeah, great. So now how about the other part, the rental price of capital? So how is the increase in labor going to affect the rental rate of capital? Okay, so let me not delete. Yeah, so let's find how this is going to affect the rental rate of capital. Just push this thing upwards like that. Great. So how is this thing going to affect the rental rate of capital? What we know is that the rental rate of capital, okay, because remember we said that any profit maximizing firm is going to hire extra units of capital up to a point where the marginal product of capital is equal to the rental rate of capital. Okay, so how then can we find the impact? Okay, how then can we find the impact of this on the rental rate of capital? So what we know is that the rental rate of the real rental rate of capital is R over P, and this is equal to the marginal product with respect to capital. Okay, so this means that to find the impact of the increase in labor on the real rental rate of capital, we have to compare R over P1, okay, the real rental rate of capital, the initial one, to the second one after the increase in labor. Okay, after the increase in labor. So in short, we should just get the marginal product with respect to capital, the initial one before the increase in labor, and then the other one after the increase in labor. Okay, so this is just marginal product with respect to capital, which we can call 1, and this is just a derivative of Q with respect to K. Okay, and since our output is AK to the power 0.3, labor to the power 0.7, getting the marginal product of capital will leave us with 0.3 AK to the power negative 0.7, then labor to the power 0.7, right? So that's our first the initial real rental rate of capital. Okay, the second one will be after the increase. Okay, after the increase, so change in Q per change in per change in K, of course, after the 10% increase in labor. Okay, after the 10% increase in labor, so this will be 0.3 A K to the power negative 0.7. Labor has increased by 10%. Okay, so it will be 1.1 to the power 0.7. Then we'll multiply this again by labor to the power 0.7, like that. Okay, then we'll have to get the ratio of the two. Okay, in short, we have to do marginal product of K2 over marginal product of K1. Okay, so this will be 0.3 AK to the power negative 0.7, 1.1 to the power 0.7, then L to the power 0.7, this divided by the initial marginal product, which is 0.3 AK to the power minus 0.7, then labor to the power 0.7, so that this and that will go, then the labor will cancel. We are remaining with 1.1 to the power 0.7, which will give us 6.9%. Remember, the logic is just as we've done previously. You convert it. When you punch 1.1 to the power 0.7 on the calculator, it's obvious that you're going to get 1.069. Okay, then you remove a 1, you're going to get 0.69. Now multiply this by 100, which will give you the 6.9%, this one. So this shows that if you increase labor, right, the real rental rate of capital, or the real price that you pay capital, will be expected to increase. The reason is simple. As you are increasing, an increase in the employment of one factor, will increase the payment to the other factor, to the opposite factor. Why? Because as you're increasing the number of people you're employing, you are reducing the marginal product with respect to labor, but at the same time you're increasing the marginal product with respect to capital. Therefore, the amount of money that you're supposed to be paying capital should be rising, because the marginal product of capital will be rising as the marginal product of labor is falling. So that's the logic there. Can we find the impact of this on the real wage? Yes, we can. We do the same. We have to find the real wage 1, which is just the marginal product with respect to labor 1. Okay, and since our production function is Cobb-Douglas, which is Q is equal to AK to the power 0.3 labor to the power 0.7, getting the marginal product with respect to labor, this will give us 0.7 AK to the power 0.3 labor to the power minus 0.3. You see that? So this was before the increase in labor. After the increase in labor, okay, after the increase in labor, this will be 0.7 AK to the power 0.3. Labor has increased by 10%, which is 1.1, but now this will be raised to the power minus 0.3. Then again, labor to the power minus 0.3. Okay, then you divide, you make a ratio, and this ratio should be MPL2 over MPL1. Right, so this will give you 0.7 AK to the power 0.3, then 1.1 to the power minus 0.3 labor to the power minus 0.3. This whole thing, you are dividing it by the initial marginal product with respect to labor, which is 0.7 AK to the power 0.3 L to the power minus 0.3, like that. So this guy will go and that guy will go, the labor will go. You're going to remain with 1.1 to the power negative 0.3. Okay, yeah, when you punch this, obviously you are getting 0.972. So since the benchmark is 1, okay, since the benchmark is 1, anything below 1 shows that there's a reduction, and anything above 1 shows that there's an increase. You interpret this the way we interpret deflator and the CPI and the like. Okay, so you have got 0.972. When you do 1.1, you raise this to power minus 0.3, you're getting 0.9718, something like that, right? Which is just 0.97, or maybe let's write it in full. Let's say correct it to 4 decimal places. So this will be 0.97, then 18. Okay, now do this. When you subtract a 1 from this, okay, subtract a 1 from that, you're going to get 0.00. So this will be minus 0.028. Okay, what does this mean? What does this mean? This shows that, oh yeah, multiply this by 100. Okay, so you multiply that by 100, this will give you negative 2.8. So this shows that there was a 2.8% reduction. Okay, so there was a 2.8% reduction in the real wage after the increase in labor. In short, as you are increasing the units of labor, let's say you're a firm, you're employing more, you're employing extra units of labor. The point is that these people are bringing in, their marginal product will be reducing, and as their marginal product is reducing, even the real wage that you are giving them should be falling. Therefore, an increase in labor force equal to 10% will just lead to a reduction in the real wage. Okay, so this will lead to a reduction in the real wage. So that's with part B, sorry. Then part C is saying, suppose that a gift of capital from abroad raises the capital stock by 10%. What happens to total output, rental price of capital, and the real wage? So for this one, won't solve it, because it's more like a replica of B. You're just doing the same things that we're doing there on part B. You do the same thing to find the impact on output, get the initial amount of output before the increase in capital, get the second one with the increase in capital. So since capital has increased by 10%, it will be the same thing. Like our y1 will still be the same production function, which is ak to the power 0.3 labor to the power 0.7. Then now our y2 will be ak to the power 0. No, it's capital that has increased, so this will be capital has increased by 1.1, capital, then everything to the power 0.3, then you have got labor to the power 0.7. This will be your y2. Then just get the ratio y2 over y1, which will be, let me just solve it, which will be a then you have got 1.1 to the power 0.3, then you have got capital to the power 0.3, you have got labor to the power 0.7. You are dividing this by the initial one, ak 0.3, labor 0.3, like that. So you cancel the a's, you cancel the capital and the labor. This will give you 1.1 to the power 0.3, like that. Okay, just like that. So when you punch 1.1 to the power 0.3, you end up getting a 2.9%, which means that after this increase in labor, in capital by 10%, our output has increased by 2.9%. Okay, so that is what it means. And then to find the impact on the real wage and the real rental rate of capital, you do the same thing just as we've done previously. Okay, where you have to find where you have to find this in rate. So to get the impact on the real wage, okay, to get the impact on the real wage, we know that we'll just have to compare real wage 1 to real wage 2. Okay, real wage 1 to real wage 2. So our real wage 1, okay, our real wage 1, we know that real wage is just W over P, which is the marginal product with respect to labor. Okay, which will just be, since our production function is ak to the power 0.3, then labor to the power 0.7, then this will just be 0.7 ak to the power 0.3 L to the power 0.7, right, before the increase in capital. Then after the increase in capital, okay, let's get the marginal product with labor, given that capital has increased by 10%. So this will be 0.7 A, then 1.1 to the power 0.3, capital to the power 0.3, then labor to the power 0.7. Then the next thing is just to get the ratio. So this will be MPL2, of course, after the increase in capital, divided by MPL1 before the increase in capital. So this will be 0.7 A, growing at 1.1 for capital, 0.3, then K to the power 0.3, our L to the power 0.7. This whole thing divided by the initial initial marginal product with respect to labor before the increase in capital. Then labor to the power 0.7, like that. So that we cancel 0.7 will go, the A will go, then this guy and that guy will go. This will leave us with 1.1 to the power 0.3. So when you do this, you just end up getting a 2.9%. What does this mean? An increase in capital of 10%, so a 10% increase in capital has led to a 2.9 increase in the real wage. Remember that this real wage is the marginal product with respect to labor. So as we are hiring more units of capital, the marginal product of labor is increasing. Why? Because always remember, an increase in one factor of production leads to an increase in the payment for the other factor. So it leads to an increase in productivity of the other factor. Okay, so that is the impact on the real wage. Let's get the impact on the real rental rate of capital. So we'll do the same things. We'll do the same thing to find the impact. To find the impact on real rental. Okay, on the real rental, we'll have to get R over P1, which is just the marginal product with respect to capital 1. Okay, since our production function is a k to the power 0.3, labor to the power 0.7, this will just be 0.3, right? A k to the power minus 0.7, then labor to the power 0.7. B, this is before the increase in capital. Then after the increase in capital, we want to know how this is going to affect its marginal product. Okay, so this will now be 0.3 A, given that capital has increased by 10%, so minus 0.7, then we have got capital to the power negative 0.7, yeah. Then we put labor to the power positive 0.7. Then now we do the ratio. So it's MPK after the increase divided by MPK before the increase in capital. So this will be 0.3 A 1.1 minus 0.7. Good K to the power minus 0.7, labor to the power 0.7. We are dividing this by the initial or the value of marginal product of capital before the increase in capital. So this will be divided by 0.3 AK to the power minus 0.7, like that. Then labor to the power positive 0.7. Then now you cancel, right? This guy you go, that guy you go. So remain with 1.1 to the power minus 0.7, like that. Okay, yeah. So in your punch 1.1, okay, 1.1 to the power minus 0.7, you're going to get 0.9355, which is like 0.9355, like that. Then do the same thing. Can you subtract a 1 from this? Yes, you can. Okay, so that you end up getting a negative 0.0645, like that. So what does this mean? This means that, so multiply this by 100. Okay, when you multiply this by 100, you get the change. Okay, so there is a 6.5% reduction in the real rental of capital. Why is there a reduction? Okay, why is there a reduction? There is a reduction because you are now employing more units of capital. The more units of capital you are hiring, the lower the marginal product of capital. And since the marginal product of capital is falling, it means that even the rental rate of capital is also falling. So there is a reduction. There is a reduction in the rental of capital, the real rental of capital. Great. So that is how we do the analysis there. Okay. Then let's look at the last part. The last part is very simple because there is now an increase in technology. What we know is that an increase in technology leads to an increase in the marginal product of labor, marginal product of capital, and it also leads to an increase in output because you are increasing you are increasing technology. So an increase in technology increases the productivities of these two factors of production. So we should expect an increase in all of them. So output will increase, product with respect to labor will increase, the product with respect to capital will also increase, Yeah, so with technology, actually the increase will be the same, the 10% throughout, so yeah, so just do the same thing. Find y1, find y2, compare. Find mpk1, find mpk2, compare. Do the same for labor. You find that the increase will just be the same. So I'll just do for one, then it's your duty to confirm the other one. So let's just analyze the impact of the increase in technology by 10% on output. Yeah, on output. Let's do with output. Okay. Hello?
Well, we have to meet as early as possible.
Oh, to discuss the Bine.
So that we can release the technology. Because even my questions are different technology.
Imewakamba mulikuti. Alright, so to find the impact on output, to compare y2 to y1, where y2 is after the increase in A. Okay, so A is now the one that is increasing by 1.1, 10%. Then we put our A, K. Everything this side will just be the same. 0.7 there, sorry. Then you will divide this with the one before. You see? Labor to the power 0.7. This will collapse, which means that the increase in output after the increase in A is just 10%. So you increase technology by 10%, output was increased by 10%. So try the one for labor and capital. You will see that the logic is just the same. There will still be a 10% increase. Alright, so until next time, boom, it's a bang.